All right, everyone, let's go over SPSS Bivariate Linear Regression assignment. So you got data from a bunch of students, got ages, you got sex. Sex is coded, similar to the correlation assignment with 1 equal to male, 2 equal to female. So again, if I turn the labels on and off, you can see there are numbers under there. Self-esteem, assertiveness, healthy lifestyle, emotional intelligence, all of these, higher value is more of the thing, more self-esteem, assertiveness, etc. Let's see. The goal of this analysis is to find the one variable that best predicts the student's self-esteem based on the strength of the correlations of the potential predictors with self-esteem, and then have the SPSS estimate the bivariate linear regression equation to predict self-esteem from this one best predictor variable. Round everything to 1 decimal if it's a percentage, 2 decimals for everything else. All right, well, let's do this. So first thing is to obtain descriptive statistics for all variables using the SPSS descriptives or frequencies procedures. So why are we doing this? At the very end of this, you do have to write up APA format results section. So now write up the results of an APA results section and using the template as a model. So what is that? Let me scroll back up to the top here just so we get there. I brought it up. This is the template. So it's an example of predicting current salary from variables. So again, we're going to be typing over stuff in here. But note among the different things, table 1 is a table of descriptive statistics. It's got range, mean, and standard deviation for continuous variables. And then for sex, it has the number and percent male and female. And this one actually had a second variable that was categorical as well. It was minority status, white and not white. We won't be needing this when we write it up. So we just got to get means and standard deviations for continuous things. So that's scale of measurements at our interval or ratio. And for sex, it's our only nominal variable. We need to get percentages and sample sizes. So that's why we have this whole thing. So let's go ahead and do that. So under Analyze, Descriptive Statistics, and Descriptives, I'm going to throw everything in the box on the right except for sex because everything, all these are interval or ratio. This is nominal, so remember it's ones and twos. 1 is male, 2 is female, so we're going to leave it out for a sec. Under options, we're getting mean, we're getting standard deviation, we're getting minimum and maximum. So note that in the table here, the range isn't the range, it's actually highest and lowest or min and max. So it's not the range that where you actually subtract those things. So I'm going to click OK. And there's our descriptive stats we need. So for age, for example, it's 20 to 45, mean was 27.77. And the standard deviation was 6.79. So anyway, let's just take a look at it. So there's the range for self-esteem was 69 to 187, mean of 122.37, standard deviation of 17.47. That's where these came from. Age was 20 to 45, right there. 26.77 and 6.79 rounds to 6.80. For assertiveness, we've got 75 to 175, a mean of 115.93, standard deviation of 17.44, right there. For healthy lifestyle, range of 73 to 148, mean of 102.12, and standard deviation of 12.36. Finally, emotional intelligence is a range of 40 to 145, mean of 99.50, standard deviation of 28.73. All right, I got all these. Now for sex, we've got to do a different procedure. We got to do frequencies. So analyze descriptives frequencies. I'm going to put sex in the box. You don't have to get any statistics, just click OK. That'll get you what you need. All right, so for males and females, we've got 17 males, 28.3%. Right there. For females, there was 43 and 71.7%. And that's going to end up going into a table like this in your APA write-up. Like that. You will need to delete these rows, which, by the way, is highlight them, right-click. Oh, there we go. Right-click, delete rows. We'll get rid of those rows. Bam. And that would be the table you needed. I'm going to hit undo, though. All right, scooting on. Let's see what's coming up. Calculating correlations among all variables. We're going to use the correlate procedure that you learned already. So we're going to get two-tailed correlations. We're going to enter self-esteem first and then everything else. So let's go ahead and do that over here. Analyze, correlate, bivariate. Self-esteem, that's the thing we want to predict, so we put it in first. And then a little trick here, you can click them over one at a time, or you can click the first one, hold down Shift, hit the bottom one, it highlights them all. Click them over. We want two-tailed. I tell you to click Show Lower Triangle Only. You are welcome to get means and standard deviations again if you want them, but we already got them, so I'm not going to. So click OK. And we get a correlation matrix. So why did we get this? Well, if you look at your write-up, the next thing that comes after describing, just sort of describing the descriptive statistics that were here, is correlations of current salary, which is what they're predicting here. That would be self-esteem for you, and all predictor variables. This is a correlation matrix, all filled in fancy. So we need, we're going to need these numbers so that we can write over these numbers and these variables as well. So let's see what we got. We did it in the table below, fill in the correlations, okie dokie. So self-esteem, age, sex, assertiveness, healthy lifestyle, emotional intelligence. That's the order we got here. So let's start with age. So what we're going to be doing here is rounding the Pearson correlations to two decimals. And then we're going to be putting stars on the ones that are statistically significant, the ones that have a sig that's less than 0.05. So do note that SPSS does a good chunk of this for you already. Scooting on down, the ones that have stars, whether it's 2 stars or 1 star, they're going to get a star in your table over here because they all have SIGs less than 0.05 if they got a star. So 0.14, no star. Oops, there we go. 0.02, no star. 0.51 with a star right there. 0.09, no star. Negative 0.03, no star. Scooting on over, next row, or next column. Negative 0.06, no star. 0.26 gets a star because its sig is less than 0.05. 0.19, and then finally 0.23. Neither of those get stars. Their sigs are not less than 0.05. Over here, negative 0.01, no star. 0.02, round it, no star. And also 0.02, no star. Boom, boom, boom. Finally, you get 0.17, 0.19. Neither of those are significant, so no stars for either of those. And then finally, negative 0.04, no star. That's the last one here. So there's only two things that are real correlations in here. It's assertiveness with variable 1, so that's self-esteem, and assertiveness with variable 2, which is age. So self-esteem and age, are related to assertiveness. This is the one we want to predict, so that would have been a better way to say that. So what's related to self-esteem, variable 1 here? The only thing that's related is assertiveness. Right, so assertiveness is the only one that has a correlation with variable 1, column 1, which is self-esteem. None of these were significant, so assertiveness looks like it's going to be the best predictor. Assertiveness is also associated with variable 2, which is age. All right, using alpha 0.05, describe all the significant correlations you find among the variables. Make sure to be specific when you describe them, higher x associated with lower y, etc. So the easy way to do this is because assertiveness is involved in both of the significant correlations, you could say higher assertiveness, because both of these are positive. Higher assertiveness is associated with higher variable 1, self-esteem, and variable 2, age. So more assertive people tended to have higher self-esteem and be older. Higher assertiveness is associated with having higher self-esteem and being older. Which one variable is the best predictor of self-esteem? Well, again, one is self-esteem. The only variable associated with it is assertiveness. So that's going to be your what you use to predict self-esteem is assertiveness. Why did I pick it? Well, it's literally the only variable that's significantly related to self-esteem. So it has the strongest correlation, but it's also the only one that had any significant correlation with self-esteem. All right. So let's get a scatter plot. So getting a scatter plot between the variable we want to predict, self-esteem, and the variable that is the predictor, which is assertiveness. We'll go up to graphs, down to scatter plot. Simple. It does matter now which variable you put on y and x. You always put the variable you want to predict on y, so self-esteem. X is the variable you're using to predict the other one, so that would be assertiveness. We're predicting self-esteem based on assertiveness because it's the only variable that was significantly related to self-esteem. All right. So I tell you to make it APA format, so I'll take you through all that. So click OK. And that gets us our scatter plots. It looks like a positive relationship, but let's throw the line in and make this APA. So what do we have to do? We have to start both axes at 0. Get rid of grid lines, throw in the line of best fit. Let's do all that. So double click. Under elements, I'll click fit line at total. While I'm in here, I'm going to unclick attach label to line. It gets rid of the little label. All right, there's our line. I also want to, we can do this in any order. So I'm going to go to options. I'm going to hide the legend. That's going to get rid of this thing right here. If I hide the legend, under options, I'm going to say hide grid lines. All I got to do now is start both axes at 0. So I'll double click on the axis, go to scale, change the low minimum to 0, click apply. I'll click on the other axis. It's a little faster way to do it. It tells me the lowest is 60. I'm going to start that at 0, hit apply, close. And that's an APA plot. So I will close the edit mode, and eventually you'll be copying this just like that. And we did it because guess what's coming up in the write-up? A scatter plot. So we'll just be pasting it in here like that. All right, so let me undo though, because this is the template. So let's see, copy the APA scatter plot in the space below, which I did. Boom, there it is, pasted it in. Does the relationship between assertiveness and self-esteem appear to be linear? That is, does a line do a good job of describing the shape of the relationship between the variables? That is, most dots are fairly close to the line. You got a couple funky ones, like this one's a little funky. Maybe that one's a little far, but they are fairly close to the line above and below. So I'd say, yeah, it looks like a linear relationship. It's not like obviously curvy or something. So yes, we're going to calculate the actual regression equation now. So analyze, regression, and linear. Excuse me. The dependent variable is what you want to predict. So that's self-esteem. Independent variable is what you're using to predict self-esteem. That's assertiveness. And got some options over here. So under statistics, you want to click this one that says confidence intervals. I don't think, part and partial, we doing part and partial, dependent. Confidence intervals continue. Okay, so no, that must be next semester. So click OK, got those confidence intervals. Click OK. It's going to make that regression equation for predicting, for predicting self-esteem from assertiveness. That's it. This is your regression. Let's kind of go through it. What percentage of variability in self-esteem is predicted by assertiveness? That is, what is the value for R squared in the model summary table? R squared in the model summary table is right there. It is 0.259. That is the proportion. I ask for a percentage, so multiply this by 100, you get 25.9 right there. So we can predict 25.9% of the variability in self-esteem just by knowing someone's assertiveness value. What percentage of variability in self-esteem is not predicted by the model? Okay, well, if we know 25.9% is predicted, 100 minus that will give us what we can't predict. So we don't know why their self-esteem varies, but it's not their assertiveness. So I'll do 100 minus 25.9 gives you 74.1. That's the answer. So 74.1 of the variability in self-esteem is associated with other stuff that we can't predict at this point. On average, how different would you expect the predicted self-esteem scores in the model to differ from actual self-esteem scores? That is, what is the standard error of estimate in the model summary table? Model summary, standard error of estimate is 15.170, rounded to 2 decimals, 15.17. That's where that comes from. In case anyone cares, what is that? So this line is our prediction line. So if you are, say, 100 assertiveness, where this line intersects, we would predict your, I don't know, 104 or something. Wherever this line intersects over here on self-esteem, maybe it's 100 and 100. If you had 100 assertiveness, we predict you had 100 self-esteem. That's how the line works. If you had 150, we predict, I don't know, maybe it's 150, 145 self-esteem. So what this number here is the difference of people's actual self-esteem scores from this prediction line. So it's the difference between all these dots and what we predict for them on this line. It is the standard deviation of the regression line. So using this little doohickey here, f with degrees of freedom regression, degrees of freedom residual is equal to some number to 2 decimals, p less than or greater than 0.05. In the ANOVA output table, so this is an APA format for writing this thing up. And the guidance on the last slide of the lecture, write the regression ANOVA results in APA format. So what am I saying? You got to fill this thing in using this table right here. So that's what we've done here. So we've said DF regression, DF is 1. That's where that came from. DF residual is the next piece. That is residual DF, degrees of freedom, is 58. So 1 in 58 is equal to the actual F value itself right here. That is 20.26 is what we would round to, 20.26. And is the sig less than or greater than 0.05? That's what we got to pick for this part. Oops, this part right here is P less than or greater than 0.05. That is, P is sig again in APA format. Sig is definitely less than 0.05. So we put P less than 0.05. Scooting on down in the table below. Fill in the regression model coefficients using the values in the coefficients output table. Why are we doing this? Well, if you look at the APA write-up, scooting on down, you'll note, first of all, here's that F value we just did. There's the R squared that we just looked at, the proportion of variance accounted for. And in this case, this was salaries. So this is going to be that 25.9 for us. And then scooting on down, there's a little table, final table here, that is your summary of your regression. It is this coefficient stuff down here. So I have you fill it in on the worksheet right here so that it's easy for you to then recreate this table. Let's do it. So B is B, standard error is standard error, beta is beta, T is T, P is sig, and 95% CI is 95% confidence interval. That's this thing. So 95% confidence interval, lower and upper, lower level, upper level. So that's where these numbers come from. So for the first one, which is your intercept, your constant, or where this line up here intersects this up and down axis, apparently it's 63.27. How did I know that? Right there, 63.27. Standard error of 13.28. No beta for this, so it's blank. T-value is 4.77. Sig is less than 0.001. It gets a little star on it, meaning it's significant. 36.70, you'd round that to for the lower limit. Upper limit is 89.85. That is for our y-intercept. Now, our predictor is assertiveness, so it's the next row. We have a B of 0.51, standard error of 0.11. Our beta is also 0.51, right there. Our t-value is 4.50. Sig is less than 0.001, and it gets a little star because it was significant. That is, it is less than 0.05. Our confidence interval is 0.28 from right there, and 0.74 right there. And that fills out the table. So once you have this table filled out, you can fill out the general form of the regression equation, which is a predicted y value for the dv, in our case, that's self-esteem, will be equal to the b from the table above for our predictor, which is 0.51, times whatever x value we want to pop in there. So we just sort of put x at this point, x assertiveness, and then we'll be adding we'll be adding the B for the intercept, 63.27. So we're just filling in the B and the A is what we got to do. So here we've done that. We've said a Y for predicted DV, which is Y for self-esteem, is equal to 0.51, 0.51. That is the B for our predictor assertiveness. We said X is assertiveness here, just to be more explicit. Plus, we add the B for the constant, 63.27. So all we did is take this thing right here and fill in B, 0.51 right there, and the A, 63.27 right there. And now we can predict any Y based on any X value we put in here. So knowing someone's assertiveness, solve it, you'll get someone's self-esteem. So number 12, how much of an increase in self-esteem does the model predict for a 1-point increase in assertiveness? That is, what is B for assertiveness? Well, it's 0.51. So for a 1-point increase in assertiveness, this is the increase you would predict in self-esteem, about half a point, 0.51. So the answer here is 0.51. All right, so here is, this is literally the answer from here. So anyway, using this all filled out correctly, what is the self-esteem you would predict for each of the following assertiveness values? 99 assertiveness, what would we predict their self-esteem to be? Well, what we've done is filled in this right here as 99 and solved it. So let's do that. So 0.51 times 99, sorry, 0.51 times 99 gets you 50.48, and then add 63.72 plus 63, or sorry, 0.27, 27. We get 113.76. The answer indeed is I filled it out here for you, 113.76, or, you can't get a decimal score for self-esteem. They're all whole numbers. So you could have said 114, round that to 114. How about a assertiveness score of 116? Well, again, using this formula up here, which is the same one we filled out here, you just fill in their assertiveness score 116 and solve for it. And that's what this is right here. So 116 got filled in there because that's the assertiveness score. Solve it. So we got 0.51 times 116. That gives us 59.16, and then add right here, add 63.27 plus 63.27. You get 122.43 right there, 122.43, or you could round it again because you can't get a decimal score. We predict that someone who had a assertiveness of 116 would have a self-esteem of 122, or you could just leave it with the decimals. How about our assertiveness score of 150? Same thing. We just pop it in that equation right there, 150, and solve. So we've got 0.51 times 150 plus 63.27, and I get 139.77, or you'd round that to 140. That's what we got here. So finally, the equation above can be rearranged so you can actually solve for assertiveness, the x value, knowing that what someone's predicted self-esteem score was using this little formula flip around right here. So all this is this formula flipped around to solve for x instead of solve for y. Instead of making you remember algebra, I just tell you, look, there's the formula. So again, what assertiveness value predicts a 100 self-esteem value? Just take this equation here, stick in an assertiveness value, a self-esteem value of 100 here, and solve it. 100 minus 63.27. That you do first, then you divide by 0.51. So I've filled it in here. Let's give it a shot. 100 minus 63.27. And then once you solve in the parentheses, divide by 0.51. So divide 0.51. You get 72 and some change. So 72.02, I guess you would round that to. But you can't get a decimal score for assertiveness, so you might want to round that to 72, which is also acceptable as an answer. So again, last step is write this thing up using the template that I give you as an APA results section. Kind of went through this whole thing. Just update this to reflect your variables instead of the ones that are used in the example for predicting salary. You were predicting self-esteem based on age, sex, assertiveness, and healthy lifestyle, and emotional intelligence. Guesses out there too. Put in your means and deviations. Put in your frequencies for sex. Delete these rows here because you don't need them. Delete. Describe the relationships that are going on. So what are what are typical values that you see up here? Describe your sample. That's what this paragraph is. Do your correlations like we did among all your variables. Fill this in based on the work we did. I think you might have to delete a couple rows here too, right? Because you only have 1, 2, 3, 4, 5, 6, 7. You only have 7 variables. Looks like there's 8 here. So again, you'll need to delete this row, right click, highlight it, delete row. We'll take care of that. And you don't need this little comment here. You still need this one though for sex, so, right? Describe the correlations. What else? Then do your little linear regression in here. Do your scatter plot like we did. So you'll paste it in there. You will have to update your titles, by the way. And anywhere it's current monthly salary, you're doing self-esteem, and prior monthly salary is what they were using to predict current monthly salary. You're using assertiveness to predict self-esteem. Down here, you're like, these are the things that we wrote up for the bivariate linear regression equation. We wrote that stuff up down in this part right here, what percent of variability, there's your F. And then fill in your table with your coefficients and just sort of say, look, here's my equation. It's in the table. It predicts 25.9% of the variability, and fill out your little table. That's it. So hopefully that's helpful, and we'll see you in a week.